So, like all the measuring instruments discussed before, a micrometer screw gauge has zero error too. If, on bringing the screw in contact with the stud, the zero mark of the circular scale coincides with the zero mark on the baseline of the main scale, then this instrument is free from a zero error. Now, we already know that the zero error can be either positive or negative. It is positive when the zero mark of the circular scale is below the baseline of the main scale. But if the zero mark of circular scale is above the baseline of the main scale, then the zero error is negative. As always, we will test our knowledge with the help of examples. The diagram on this side shows a wire placed inside a micrometer screw gauge. Let's start by closing the gap between the spindle and the stud of the screw gauge and by turning the ratchet in a clockwise direction. Next, we note the main scale as well as the circular scale readings just to find the zero error and incidentally the zero correction of the screw gauge. Our third step is to open the gap between the stud and the spindle of the screw gauge by turning the ratchet in an anti-clockwise direction. We now place the given wire in the gap as shown in the figure and turn the ratchet so that the object is pressed gently between the studs and the spindle. Moving on, we note the main scale as well as the circular scale readings to find the diameter of the given wire. We then apply the zero correction to get the correct diameter of the wire. In order to achieve the most accurate result for the diameter of the wire, we repeat a few steps at different places of the wire. We open the gap between the stud and the spindle again by turning the ratchet in an anti-clockwise direction. We repeat the steps that were initially followed and place the wire in the gap and turn the ratchet so that it is gently pressed between the stud and the spindle. We then note the reading on the main scale as well as the circular scale to find the diameter of the wire.